Good morning, class.
Good morning, sir.
ल हामीले अस्ति फ्राइडे होइन कहाँसम्म के पढाएको थियौँ? कसलाई थाहा छ? प्रोपर्टी सक्यो कि त्यो तिनवटा सकेको थियो? कस्तो थियो? सबै पोइन्ट 5 वटै सकिएको थियो? यिनीहरू अलिकति छोडेको थियो कि होइन 4वटा छ तर 5मा पनि चाहिन्छ त्यो आइसेक्वेन्ट नेभर टचेज एनी एक्सिस। मैले यो फोन नम्बरसँगको डायग्राम बनाएर देखाएँ नि होइन? जस्तो यो मैले इन्डिफरेन्स कभरको प्रोपर्टिजहरू जे हो ठ्याक्कै त्यस्तै हुन्छ, सिमिलर हुन्छ भनेर चाहिँ भनेको थिएँ होइन? ल ठिक छ, म यहाँ सुरु गरेँ नि त। अब properties means characteristics or features of isequent. The first property of the isequent is slope of the isequent is negative. That means it has a negative slope.
Screen share भएको छैन सर।
Slope of the isequent is negative. That means in every point of these properties, you should explain why these properties exist in isequent. Slope of the isequent is negative because of to increase the 1 unit of, let's say, labor, producer must reduce the sum units of capital to remain on the same level of output in isequent. That's why isequent is sloping downward from left to the right. What is the reason? To increase the 1 unit of labor, producer must reduce the sum units of capital to remain on the same level of output. That's why isequent is negative sloped. When producer moves from combination A to B, let's say, along the isequent, he or she must reduce the sum units of capital to increase the 1 units of labor. That's why it has a negative slope. You should explain these points with the diagram as well, consulting your books, because I have not mentioned detailed analysis of this because these properties are very similar to the properties of isequent. The second isequent curve is convex to the origin because the another property is important property of isequent is it is the convex to the origin, because when the producer moves from one combination to another's and from another to again another's, the decreasing amount of capital will be reduces with the increase in every additional unit of labor. That means Due to the diminishing marginal rate of technical substitutions, isequent is convex to the origin. Due to the diminishing marginal rate of technical substitution, the isequent is convex to the origin. About diminishing marginal rate of technical substitution, we will study later on. Next one, isequent curve never intersect or tangent to each other. If two isequents either intersect or tangent to each other, the different level of output will be equal at the tangency or intersection point. That's why which is not possible. I've already mentioned, I have already displayed that when two isequents, let's say IQ1 and IQ2 intersect, the different level output will be equal at the tangency or intersection point. That's why which is not possible. You should also explain detailedly by using the one diagram by intersection or intersecting or the tangency. Higher isequent represent higher level of output. In every isequent, the more number of labor and capital are consist. That's why by using the more number of units of labor and capital, obviously output will be more in the higher end isequent. That's why every higher isequent represents higher level of output. The last one, isequent never touches any axis. To produce any goods and services in any part of the country around the globe, the labor and capital are must to produce any goods and services. Without using both, nobody can produce anything around the globe. If any isequent touches either x-axis or y-axis, the 1 unit of utilization will be 0. Utilization of 1 unit factor input will be 0. If any isequent touches the y-axis, units of labor will be 0 at the touching point. And similarly, if any isequent touches the x-axis, units of capital will be 0. And without using capital, only using labor, nobody can produce anything around the globe. Similarly, without using labor, by using only capital, nobody can produce anything. That's why isequent never touches any axis. I can show you about this condition. You can see here. Let's draw the one diagram. This is the y-axis, x-axis, x, okay. This is O. Over. And let's draw the one isequence touching with, let's say, this is one isequent represents Q. It represents, let's say, 100 units of capital, sorry, output. The another isequent can be drawn by touching the x-axis like this. This is IQ equal to, let's say, it also represent 150 units. And at the point of this, let's mark here in this point and in this point. Let's give the name A and the B. In the point A, which lies on the IQ, one let me one IQ1 को A मा 100% तर के हुन्छ यहाँ labor is 0. In the B, capital is 0 because IQ1 IQ2 touches the Y and X axis at the point A and B respectively, which is not possible because without using capital we cannot produce at point B, and without using labor we cannot produce at point A. That's why the IQ never touches any axis. This is the fifth properties of isequent. So the diagram banao hai. Our next, marginal rate of technical substitution. I already discussed much about this Mrts. The rate at which the some units of capital are substituted for the one additional unit of labor. That is called marginal rate of technical substitution. It is denoted by in the short form Mrts. The marginal rate of technical substitution is the rate at which one input can be substituted for another input without changing the level of output. This is the marginal rate of technical substitution. The rate at which one input is substituted for another without changing the level of output. That is marginal rate of technical substitutions. Mathematically, it is expressed as marginal rate of technical substitution of labor for capital. This MRTSLK is read as marginal rate of technical substitution of labor for capital equal to minus dk by dl, that is marginal productivity labor by marginal productivity of capital. It can be made clear with the help of the following table. You can see here factor combination. There are 5 combinations A, B, C, D, and E. Units of labor 1, 2, 3, 4, 5. Units of capital 11, 7, 4, 2, 1. On the basis of this, we can find the margin rate of technical substitution of labor for capital. In the combination A, producer uses 1 units of labor and 11 units of capital to produce the certain level output, let's say whatever be 100,000 units or 1,000 units, whatever be. When the producer moves from combination A to B, units of labor increases from 1 to 2 units, units of capital decreases from 11 to 7 units. 11 minus 7 equal to 4 is the marginal rate of technical substitution of labor for capital when the producer moves from combination A to B. That means the marginal rate of technical substitution of labor for capital between the combination A and B is 4. Similarly, if the producer moves from combination B to C, C to D, and D to E, units of labor are increasing continuously by 1 unit, but units of capital are decreasing by the 3, 2, and 1 unit respectively. That means 7 minus 4, 7 minus 7, 11 minus 7, 4, 7 minus 4, 3, 4 minus 2, 2, 2 minus 1, 1. These 4, 3, 2, and 1 are the marginal rate of technical substitution of labor for capital in the respective combination. This is explained this way. This is a complete slide. You can take the screenshot of this. Now our question. The next our topic is okay. The marginal rate of technical substitution also can be illustrated in the following diagram. You can draw this diagram. Here, when producer moves from combination, let's say from A to B, the capital are reduced by delta K, that are 4 units, to increase the 1 units of capital from 1 to 2 by delta L. यो डेल्टा के को भ्यालुहरु हेर्दा डिस्टेन्स नि यो सबभन्दा लामो छ अनि यो भन्दा यो छोटो छ, यसले 4 रिप्रेजेन्ट गर्यो, यसले 3 गर्यो, यसले 2 गर्यो, यसले 1 गर्यो. अनि यो डेल्टा के को भ्यालुहरु चाहिँ के भइरहेको छ, डिस्टेन्स चाहिँ continuously diminishing. So marginal rate of technical substitution diminishes. That means diminishing marginal rate of technical substitution. Explanation of this diagram. The slope of isequent is Mrts Lk equal to minus MPL by MPK. This is the complete slide for this. Well, let's do a numerical example. Before go to the numerical example, let's discuss about the isocost line. I have one question to you all again about the what is price line or budget line in indifference curve analysis. In indifference curve analysis, what is price line or budget line? भनिहाल्यो तिमीहरू यस्तो पाराले त भएन नि त इन्डिफरेन्स कर्वमा पढेको प्राइस लाइन बजेट लाइनको मिनिङ भनेर सबैले खै त आउँदैन त्यो खोजेर भने भन न तिमीहरू के खालको मान्छे ISO means equal, cost means expenditure. तिमीहरूलाई त के गर्ने हो शिवानी खड्का आर लिसनिङ खड्का होइन शिवानी खै त प्रवीण चुप लाएर बसिसकिहाल्यो नि त होइन जितिन्छ सबै त प्रतीक्षा अनि कोही बोल्दैन तिमीहरू के हो कान बन्द भयो कि यहाँ साउन्ड आउँदैन
हजुर सर
व्हाट इज प्राइस लाइन इन्डिफरेन्स कर्वको छुट्दै छ प्राइस लाइनमा
हजुर
व्हाट इज प्राइस लाइन or budget line in consumer behavior indifference curve analysis
budget line is the locus of various combination of two goods in which a consumer can purchase by spending his or her given money income and market price.
Good. Now अरूलाई पनि आउँछ भन्ने म गएँ है त ठ्याक्कै आइसो कस्ट पनि त्यस्तै हो क्या त्यहाँ चाहिँ हामीसँग अघि यसले प्रतीक्षाले भने जस्तो दुईटा गुड्स छ कन्ज्युमरसँग सर्टेन बजेट छ यहाँ चाहिँ के छ हामी वी आर इन द थ्योरी अफ प्रोडक्सन वी हेभ द टु इनपुट्स लेबर एन्ड क्यापिटल एन्ड सर्टेन producer has a certain budget to spend to purchase the labor and capital. That's why the ISO cost line is the locus of various combinations of two factor inputs which can be purchased by the producers from the given money outlay. This is called ISO cost line. ISO means equal, cost means expenditure made on the purchase of inputs. The graphical representation of various combination of two factor inputs which the firm can purchase with a given amount of cost money outlay. The total cost is or outlay is the sum of the total expenditure made to purchase labor and capital. How much money is used to purchase the different units of labor and capital along the ISO cost line That is called total cost or total outlay, money outlay. So the total outlay is represented by the C, which is equal to total expenditure on labor plus total expenditure on capital. In mathematical form, in symbolic form, as an equation of IC cost can be expressed as C equal to PL into L plus PK into K. Total expenditure on labor is obtained by multiplying the units of labor by its prices PL plus units of capital by its prices, that is PK, price of capital, which is represented by the rate of interest. So finally, we can express the IC cost line as C equal to WL plus RG. W is wage rate, R is interest rate, right? C1 total expenditure made on the purchase of labor and capital. W wages multiplied by units of labor plus rate of interest multiplied by units of capital. That value will be equal to the total outlay or money outlay, total cost or money outlay. This is the equation of IC cost line. On the basis of this equation, we can draw the IC cost line. Derivation of IC cost line by using some numerical example or values. Let's say the producer has 200 rupees to spend on to purchase the labor and capital, and the price of labor is 10 rupees and price of capital is 20 rupees, let's say. Let's find the maximum quantity of labor and capital can be purchased by spending all budget on single input, that is either labor or capital. हामीले पहिला इन्डिपेन्डेन्ट एनालाइसिसमा के पढाएको थियो? If consumer spend entire money income on the X, how many units of X can be purchased? If the consumer spends entire money income Y, how many units of Y can be purchased? By plotting these extreme quantity of labor X and Y goods in a diagram, we get a price line or budget line. Similarly, in here, if producer utilize all the money, all the cost or budget or outlay used on the purchase of labor, how many units of labor can be purchased? You should find first. And then secondly, you should find how many units of capital can be purchased if entire budget is spent on the purchase of capital. And we will have some values, two values, and plotting these values on a diagram, we get a line, straight line joining two axes, X and Y. That is IC cost line. The equation of the IC cost is C equal to W into L plus R into K. Wage into labor, interest into capital. That will be equal to the C total cost. That is in our example in the given. That is C equal to what? 200. W is 10. L plus R is 20. Then K. If all the 200 is spent on to purchase the labor, capital will be 0. If all 200 is spent on purchase of capital, labor will be 0. You can see here 200 equal to 10 plus 20, 0. And the L equal to 200 divided 10 equal to 20 units. Similarly, if entire budget is spent on the purchase of K, the value of K will be 10 units. By plotting these 20 and 10 units of labor and capital in diagram, we get a IC cost line. Let's draw the diagram. O, X, Y, units of labor, units of capital, and 10, 20, 5, 10. The extreme amount of the capital is 10 units, extreme amount of the labor is 20 units. By joining 10 and 20, we get a IC cost line. This IC cost line is drawn on the basis of C equal to 200 and W equal to 10, R equal to 20. यसैको बेसमा ड्रा गरे. This is the how we can derive the ISO cost line by using the some numerical facts, numerical values. ल अब यो ल केही छ कन्फ्युजन? AB is the ISO cost line. This much for today. Bye bye. Have a nice day.
Thank you.